Good morning, children. Stay safely at home. So, I am starting the next chapter today, that is magnetism. Now, you know that the first natural magnet, that was lodestone, Lodestone, lodestone. And what is lodestone? It is nothing but ore of iron oxide, and it was found in Magnesia. So the magnet, the term magnet, it has come from the word Magnesia. Okay. Now, what is magnet? Generally, how we define a magnet? The substance which attracts iron, alright, or which set itself along north-south direction when suspended freely is known as magnet. Alright. So, what is a magnet? The magnet which exhibit these two properties. What are the properties I said? The first property, it can attract a piece of iron, cobalt or nickel, or when it is suspended freely, it will set itself along the geographic north-south direction. Then it is considered as magnet. And you know that there are different kinds of magnet. When you are considering a magnet in the form of a bar, then that is known as bar magnet. And every magnet is having the maximum attraction. These are the terms already you studied in the earlier classes, that if you consider a magnet, then you will see the attraction is maximum at one point at the end of the magnet. So that point where attraction is maximum is known as pole, and the end of the magnet which set itself towards the geographic north direction is known as the north seeking pole or north pole, and the pole of a freely suspended magnet which set itself along the geographic south direction is known as the south seeking pole or known as south pole. So every magnet is having two poles, north pole and south pole. And when the magnet is in this form of a bar, then that is known as the bar magnet. And when the magnet is in the form of a horseshoe, okay, then it is known as the horseshoe magnet. And you know, horseshoe magnet also having two poles, north and south pole. This is known as the horseshoe magnet. Okay. Then there is a magnet which is known as U magnet also. It just look like U. So this is known as U-shaped magnet. Then there is a magnetic needle. Magnetic needle is like this, which is pivoted at the point freely, so it can rotate about this fixed axis. So it is also having north and south pole. Then another one is in the small box. You will see a small magnetic needle is kept, which is known as magnetic compass. So these are the different types of magnets generally we are having. Okay. Now consider this experiment. Suppose you have taken one bar magnet and you have taken certain iron nails. Okay, you have taken iron nails like this. Now, if you take any pole of the magnet, you may take any pole, any side, any corner of the magnet to the iron nail, then you will see that iron nail, it will get attracted by the bar magnet. Now the question is, why it is getting attracted by the magnet? Because you see, when you are bringing the iron nail near the magnet, then what will happen? At the near end of the substance, opposite pole will be induced, and at the far end, like pole will be induced. Alright. And as we know that opposite pole, they attract each other. So what will happen? As a result, the iron nail, it will get attracted. Iron nail, you can also say it as a magnetic substance. Get attracted by the magnet. Alright. So how you can write what is induced? So you see, what is induced magnetism? the temporary magnetism acquired by a magnetic material when it is kept near a magnet or it is in contact with a magnet is known as the induced magnetism. And the process by which induced magnetism is acquired is known as magnetic induction. Alright, so you must learn both the definition of induced magnetism and magnetic induction. So what is magnetic induction? The process by which a piece of magnetic material acquires temporary magnetism in presence of another magnet near it is called magnetic induction. Alright, so remember, this is the most important point regarding the magnetic induction. Magnetic induction means when you are bringing the means this is not a magnet, it is a magnetic material. Then remember this fact that at the near end opposite pole and at the far end same kind of pole will be induced. This is the most important point regarding the magnetic. So you see, regarding magnetic induction, what is the important point you have to remember? That is at the near end of the magnetic substance, opposite pole is induced. Alright, a magnetic pole induces opposite pole at the near end and like pole at the far end. Alright, so that's why always remember induction precedes attraction. Alright, now you may get the question on this topic like this, that when iron bar is brought near a magnet, why it gets attracted by the magnet, or why a magnet attracts the iron bar. Okay, what is the reason? When you are bringing the iron bar near the magnet, then what will happen? Magnetic induction will take place, and due to magnetic induction at the near end of the iron bar, opposite pole will be induced and at the far end like pole will be induced. Now as opposite poles attract each other, so what will happen? Iron bar will get attracted towards the magnet. So this is the way you can write. When a piece of iron is brought near the pole of a magnet, here you can write down this: magnetic induction takes place. Alright, then don't write and opposite pole induces at the near end of iron piece and like pole induces at the far end of iron piece. Now as opposite poles attract each other, so iron gets attracted towards the magnet. Alright, so again I am just showing it by again the diagram. Suppose this is the south pole, you have brought one iron nail near it, then here north pole will be developed and at this one south pole will develop. So you see this north and south attracting each other, so iron gets attracted towards the magnet. Now this portion you please do not draw this diagram. This diagram I have just drawn for the clarification. If there is no need to write or draw this diagram. Okay, so this is the way, this is the clarification that why a magnet attracts a iron bar. Alright, or it may come this way also, that show induction precedes attraction. Now as I said while discussing the induced magnetism, that induced magnetism is temporary. Now you can just show it by a nice experiment. So you take a bar magnet, alright. Now suppose you have taken certain nails, a number of nails, and you are bringing near the magnet. Then what you will observe? That all the nails, they will just form a vertical chain like this. Okay, so here you see this is south pole, this is north, then again south, north, south, north, south, north, south, north, south, north. This is the way magnetism is developed. Alright, now you do one thing. You hold this one nail by one finger by your hand and then you remove it. means you have removed the bar magnet, then what you will observe that all the nails, they will fall down and they will not attract each other anymore. Alright, what does it mean? Till the magnet is present, magnetism, induced magnetism is there. When the magnet is not present, then induced magnetism will be destroyed. So, induced magnetism is temporary. Now, the next term related with magnetism or a magnet is magnetic field. Now, what is magnetic field? Suppose you have kept one magnet here. Alright. Now, surrounding the magnet, the region where if you keep another, suppose you have brought another iron bar, alright, then the iron bar will feel the force exerted by the magnet, then you know that what the iron bar will do, will be attracted towards the magnet, isn't it? But you will see that suppose you have kept one magnet here, then surrounding a magnet there is certain distance, still you can experience, not you, the iron bar or the magnetic substance can experience the attraction exerted by the magnet. So that region where a magnetic substance experiences the force exerted by the magnet is known as the magnetic field of the magnet. So what is the definition of the magnetic field? The space around a magnet in which a magnetic substance experiences the force exerted by the magnet is known as the magnetic field. Now, the question is that how you can find out the magnetic field. You can find out the magnetic field by keeping a unit north pole. This is the point you have to remember, that all the definitions in magnetism, we define it in terms of unit north pole. So, unit north pole, if you keep at a point inside a magnetic field, then the force experienced by unit north pole within a magnetic field is known as the magnetic field strength of that point. And remember that magnetic field strength is a vector quantity. Now the topic I am discussing, that is the most important topic of this chapter, that is magnetic field line. Alright, what is magnetic field line? The imaginary path followed by a unit north pole in a magnetic field is known as, I would have stopped the video. Okay, is known as magnetic field line. Alright, means what? You just take a unit north pole and you leave it in a magnetic field line. Then what will happen? Depending on the force experience, direction of the force experience, it will follow a imaginary path. That is known as the magnetic field line. So just you consider, suppose I have taken a bar magnet. Here is the north pole and south pole. Then you see, whom you have to keep in the magnetic field? Unit north pole. Alright, whom you have to keep? Unit north pole. So you see, when you are keeping the north pole here near this one, the north and north, they will repel each other, whereas north and south, they will attract each other. So you will see that it will follow a closed line like this. Now, instead of taking a bar magnet, if you take a solenoid, then solenoid inside is hollow, then what will happen? Inside the magnet, the north pole, it will move from south to north. So you see, it is following this imaginary path. So path, it is having a direction. Why? Because we have taken unit north pole. So always it will move from the north towards south. So this imaginary line followed in a magnetic field by whom? By unit north pole is known as magnetic field line. Now what are the properties of magnetic field lines? Already the first property I discussed by drawing the diagram, that magnetic field lines are always closed curve and continuous curve. Closed and continuous curves. Okay. Then second point is, outside the magnet, they are directed from north to south pole. Already I have given the arrow. I hope you can remember that if this is the bar magnet, then if I draw the magnetic field lines, then you see outside the magnet it is moving from north to south, and inside the magnet it is from south to north. Alright. So outside the magnet the field line is directed from north to south, and inside the magnet from the south to the north. Alright. Now the third characteristics is very important. The third characteristics is very important. What is the third characteristics? The tangent drawn at any point on the magnetic field line gives the direction of the magnetic field at that point. What is the meaning? Understand it. Suppose there is a magnetic field line. It is moving like this. Okay. Now I have chosen one point here. So at this point, if I draw a tangent, then this tangent gives the direction of the magnetic field or magnetic field strength at that point. Okay, this diagram everyone should draw. I repeat, this diagram for this point you must draw. This is the illustration of this point. That at any point on a magnetic field line, if you draw a tangent, then the tangent gives the direction of the magnetic field strength at that point. Then the fourth property of the magnetic field lines is that very important. Third and fourth property, very important. So that's why above the third point I put 2 asterisks. I hope you have noticed that. Now fourth point, that they never intersect each other. Alright. Why they cannot intersect each other? Just try to understand it. Suppose there are 2 magnetic field lines. This is the direction of 2 magnetic field lines, and we are considering that they are intersecting at the point P. Suppose they are intersecting at the point P. Then you see at the point P you can draw 2 tangent. Alright, this is the tangent you have drawn for this line, and this is the tangent you have drawn for this line. So you see you are getting 2 tangent at one point. So you see what will happen, 2 tangents will give 2 directions of magnetic field strength at one point. Alright, which is not possible. At one point, there will be only one direction of the magnetic field strength. So, the 2 magnetic field lines, they cannot intersect each other. So, this is an important point, and question come like this, that why 2 magnetic field lines cannot intersect each other. Then, you can write down your answer point wise. So, if it comes that why 2 magnetic field lines cannot intersect each other, then you draw this diagram, show that at the point of intersection, draw 2 tangents, and then write down pointwise this way, that if 2 magnetic field lines intersect at a point, then 2 tangents can be drawn as shown in the figure. So 2 tangents will give 2 direction of magnetic field strength at one point, which is not possible. So magnetic field lines never intersect each other. Alright, and as I already mentioned, the third and fourth properties are. Now the fifth property is that the region where magnetic field lines are closer or crowded, the magnetic field is stronger. And in regions where magnetic field lines are far apart, the magnetic field is weaker. So suppose you are having a set of magnetic field lines like this. Okay, just consider this one. Now suppose you have taken a point A here, a point, suppose it is P, and suppose you have taken a point Q here as shown. Now you see, at the point Q, the magnetic field lines, there should be an arrow for every lines. Now you see the point Q, the magnetic field lines, they are crowded. Okay, so here magnetic field lines, so I can write like this, magnetic field strength How we represent? By the letter B, capital B. So you see, magnetic field at the point Q is strongest or maximum. Now you consider the point A. The point, it is relatively closer. Okay, relatively far away from Q. So what you can write, that magnetic field strength at the point Q, it is greater than magnetic field strength at the point A. Again you consider the point P. The point P, all the lines are far apart. So you can write the magnetic field at the point P, it is minimum. Okay, magnetic field at the point Q is maximum, magnetic field at the point A is greater than P but less than Q, and magnetic field at the point P is minimum. So this is the meaning of this statement, that if the magnetic field lines are closer at any point, at any region, that region magnetic field is stronger, whereas if it is far apart, then magnetic field is weaker in that. Girls, you must draw the diagram, and as I have written BQ greater than BA greater than BP, that also you must note down in your copy for the illustration of this point. Now next property of the magnetic field lines, this is also important. In regions where magnetic field lines are, you see, parallel to each other and equidistant, then magnetic field is uniform or constant in that region. This is also important, and how you may get the question, either it will be asked that draw the magnetic field lines for uniform magnetic field, then you have to draw this one, or you may get this question, if the magnetic field lines are like this, what is the conclusion you can draw? What is the conclusion you can draw? That magnetic field is constant in that region. Now, the next property of magnetic field lines is that they behave like stretched elastic rubber strings. So, now you can just explain that why the opposite pole attract each other. So, suppose there is a north and south pole. So, you see the magnetic field lines, it will be from north to south like this. Now, this one, it acts as a stretched elastic rubber string. So, if you take a straight string and then if you just release it, then what will happen? You do not hold the rubber string. You stretch it and then you release. What will happen? It will contract. So here you see what is happening. If it is left by itself, then it will try to contract. As a result, north and south pole will attract each other. Alright. So this diagram you don't have to draw, but this is one of the use of this property. Alright, that they behave like stretched elastic rubber strings. So, the topics I have discussed today, out of that, definition of magnetic field lines and properties of magnetic field lines are very important. So, you learn it and practice it also by writing in any rough notebook. Thank you, girls.